In modern power systems, the reliability and longevity of electrical equipment are paramount. One of the most critical components in the distribution network is the transformer, which is vulnerable to a specific type of electrical disturbance known as fast transient overvoltages. These transients, often caused by switching operations involving vacuum circuit breakers VCBs or SF6 breakers, can lead to insulation breakdown, winding damage, and ultimately transformer failure. To address this challenge, Hitachi Energy has developed an innovative solution known as transient voltage protection. Transient voltage protection is a patented, integrated protection system designed to mitigate fast transient overvoltages directly within the transformer. Unlike conventional external protection devices such as surge arresters or RC snubber circuits, TVP is embedded inside the transformer windings during manufacturing. It utilizes voltage-dependent resistors VDRs, also known as varistors, which dynamically respond to voltage spikes by absorbing and dissipating excess energy. Transient voltage can inflict severe damage on your electrical equipment and over time, lead to network failure resulting in costly repair and downtime. Transformers with transient voltage protection technology protect your network from failure and let you avoid complicated system revisions and costly outages. A complex problem: medium voltage, fast-acting circuit breakers have become the most popular switching technology across industries. However, the sudden drop in current that occurs when the circuit is broken causes a sudden, short-lived overvoltage known as a transient voltage. As more system studies were conducted, newer failure modes caused by such transient voltage were observed. Transient voltage protection is an advanced protection system integrated into Hitachi Energy's distribution transformers, both dry-type and liquid-filled. It's designed to shield transformers from fast transient overvoltages that occur during electrical switching operations, especially with vacuum circuit breakers VCBs or SF6 breakers. These switching events can produce sudden voltage spikes that damage transformer windings, leading to premature failure, costly downtime, and expensive replacements. Strategic varistor placement. TVP uses varistors, voltage-dependent resistors embedded directly into the transformer windings. Protection mechanism: absorbs and dissipates transient voltage spikes. Prevents reignitions and resonance amplification during switching. Keeps voltage peaks below insulation damage thresholds. This internal protection is network agnostic, meaning it works across various grid configurations without needing complex system studies or external surge protection devices. When a switching operation occurs, such as opening or closing a VCB, fast transients can propagate through the system. These transients typically have high frequency up to several megahertz, short duration microseconds, high peak voltage often exceeding 60 to 80 kV. TVP varistors are strategically placed within the transformer windings to intercept these transients. As the voltage rises beyond a safe threshold, the varistors conduct and clamp the voltage, reducing the peak stress to around 40 to 45 kV, which is well within the insulation limits of modern transformers. Key feature: our internal integration. TVP is built into the transformer, eliminating the need for external components. Real-time response: the varistors react instantly to voltage spikes, protecting insulation and windings. Maintenance-free. Once installed, TVP requires no additional servicing or monitoring. Network agnostic, effective across various grid configurations and switching environments. Applications: TVP is particularly valuable in environments where switching operations are frequent or where grid conditions are unpredictable. Common applications include industrial facilities with high switching activity, renewable energy systems e.g., solar and wind farms, urban substations with compact layouts and sensitive equipment, utilities seeking long-term asset protection and reduced maintenance. The stress from extreme transient voltages can damage a range of magnetic equipment in the network, including transformers, motors, pumps, and measurement equipment with repeated switching over time. Switching transients are perhaps the worst voltage stress that a transformer could be subjected to. Due to complex system variables, the exact nature of the damage was often difficult to predict or even identify. There have been some proposed solutions like RC snubber circuits and surge arresters. However, they are incompatible across all networks and configuration and often expensive to install. A simple solution for a complex problem: transformer with transient voltage protection. TVP technology by Hitachi. ABB Power Grids provide complete protection for your electrical systems at every single switching instance. The strategically positioned varistors across transformers windings protect them from any overvoltage caused by virtual current chopping and resonance amplification. This prevents voltage peaks from ever reaching levels that could damage the insulation in our transformers equipped with TVP. Moreover, its network-agnostic design makes it the best fit for you, no matter what your needs. During the early 90s, the vacuum circuit breaker VCB technology had become the quintessential electrical switching equipment. The VCB came with a highly efficient current chopping capacity that provided a clear advantage over the then incumbent mechanical air switches. However, like every other technology, the VCB2 had a challenge that required mitigation. The current chopping capacity also gave rise to extreme voltage transients that lead to the creation of specific failure modes for other equipment in the system such as transformers. On opening a VCB, the metal vapor from the contacts burns an arc with the heat supplied by the current, causing it to approach zero. While this helps in effectively de-energizing the system, the sharp drop in current, coupled with the trapped magnetic energy in the inductances on the load side, generate a sudden increase in voltage at transient overvoltage. One such stress incident in combination with unique circuit characteristics can produce serious voltage transients disrupting critical distribution equipment like transformers. The severities of the voltage surge are determined by circuit characteristics. Some of the more threatening network characteristics that increase the risk of switching transient damage include less distance between the transformer and circuit breaker, high upstream capacitance, switching of inductive load, and switching parameters of the circuit breaker. Currently, several surge protection measures exist to safeguard the primary winding of a transformer from VCB-induced transient outages. However, they do not either offer complete protection or are too expensive for installation and regular maintenance. For instance, surge arresters provide basic protection from overvoltage stress to ground by restricting the voltage peak of the transient voltage waveform, but do not provide any significant phase-to-phase protection. This issue is usually addressed by combining a surge capacitor with an arrestor. While this helps in slowing down the degree at which the overvoltage rises and capping the peak voltage, it does nothing to offset direct current DC. Besides this, there is another way to restrict current chopping virtually. By integrating a resistor with the capacitor and the arrestor, grid administrators can reduce the DC offset of the transient overvoltage waveform and reduce the potential of virtual current chopping. The resistor, capacitor, and surge arrestor together form a solution known as the RC snubber circuit, which has no known field failure cases, but its implementation results in the increase of transformer size and undesirable capacitor maintenance. Additionally, the installation cost of RC snubber circuits can go upwards of $20,000 USD and require system studies for sizing, which is often not a feasible option for organizations. In comparison to all the conventional transient protection measures available currently, Hitachi ABB Power Grid's transient voltage protection TVP technology for transformers serves as a holistic solution that efficiently controls internal voltage peaks with minimal impact to the overall transformer design. Hitachi ABB Power Grids developed this technology so that distribution transformers can safely operate with vacuum circuit breakers in any network without the need of a system study. These transformers are specifically engineered using winding varistors that are strategically integrated with the transformers to protect them for transient surges. Winding varistor-based protective systems provide a simple solution to the rather complex problem.